Right. So I'm going to talk about how to successfully implement a cloud security platform. Yeah, so what I'm going to do here, I'm going to talk about cloud security platforms in quite a generic sort of way. So by cloud security platforms, I mean platforms such as Wiz, Palo Alto Prisma, Aikida, all these different vendors that provide cloud security platforms. So I'm going to start by talking about typical requirements from an organization that wishes to put in place one of these platforms. Then I'm going to go through some of the implementations which I've been involved with over the last 3, 4, 5 years, or maybe more actually. I'm going to talk to you about some of the mistakes that were made along the way, and also the successes. So from that, I will extract hopefully some learnings, from those experiences, and then just distill that into some short takeaway do's and don'ts for any of you that are watching this who might also be considering engaging in similar programs yourself. So that's the agenda. Let's get going. Okay, so what are the typical requirements that for a cloud security platform? So firstly, cloud security platforms these days are, the requirement is typically for multi-cloud. Most organizations now have more than one cloud. They might have AWS, Google Cloud, Azure, Oracle. So usually the requirement is that there's some sort of centralized platform that monitors and helps to protect the security of all of these different types of cloud that a particular enterprise might use. So the platform needs to integrate with these and have good coverage. As well as that, there's a requirement for the platform to integrate with some sort of identity provider so that the administrators who need to log on to the platform and make changes, or the developers who might want to look at their security issues, can log in with their corporate identities. So this could be Entra ID or Okta or Google Workspace. So that integration is essential as well. These days, more and more organizations are moving to containers and Kubernetes or ECS, and these container clusters are almost like mini data centers in their own right. Sometimes they're within another cloud, using, for example, EKS in AWS or AKS in Azure, but sometimes they're even on-prem. But regardless, these need to also feed into this platform. And it's not just the cloud platforms and containers that the platform needs to integrate with. Up-to-date, a good cloud security platform will also integrate with version control systems. So this, could, for example, be GitHub. Not only that, but there's a need to integrate with to send notifications to, for example, Slack or Teams or email, and in many cases, to automatically create tickets, which could be in Jira or ServiceNow. So all of these integrations are some of the aspects of the requirements. But it's not just about the integrations. It's also about what type of events are organizations typically looking for now, from these types of platform. So the first one is cloud configuration, or rather misconfiguration. So this could be, the classic sort of case of looking for a storage S3 bucket that's open to the world, or it could be looking for a virtual machine in Azure that is running Windows and has RDP ports open from the entire internet. So looking for those sorts of misconfigurations, that's certainly pretty much always a requirement for these platforms. But it's about a lot more than that now. So cloud configurations, provide sort of point-in-time snapshots, and they may be fairly frequent, like once a day, but they don't necessarily provide, actual events. So cloud events is another important integration, and by that I typically mean cloud control plane administrator events. So this could be an administrator making a change in the console in AWS, or it could be a CI/CD pipeline that is deploying something to Google Cloud. So that's really what I mean by cloud events. So that's those control plane actions or data actions. And then there's a need for scanning and detecting potential vulnerabilities. So these range from, or can range, depending on the detailed requirements. They can range from vulnerable source code, libraries and dependencies, to app security issues like insecure coding. Then the next sort of area is really around threat detection. So this is where increasingly organizations want to know if there is an attacker that's maybe got an initial foothold on a compute platform and is trying to move laterally or escalate privileges. So this usually requires runtime sensors or sidecar containers if it's Kubernetes, or some sort of agent if it's a virtual machine. For that real-time detection of threats. Think, Microsoft Defender for endpoint, but the equivalent in the cloud. And then it's not just about threats and issues and vulnerabilities and risk. It's also about compliance in many cases. So most organizations will want to report on compliance to different frameworks such as NIST or ISO 27001 or Center for Internet Security best practice. So, that's the sort of typical set of, quite comprehensive requirements that organizations will have, nowadays for a cloud security platform. So, moving on. The implementations which I've been involved with over the last few years, and I'm drawing my sort of lessons from today, are firstly, they're all in the UK because that's where I live, in London, as you can probably tell from the accent. So the first one was at OVO Energy. So OVO Energy is one of the largest retail energy providers in the United Kingdom. As you might expect, it has personal information from many millions of household customers, for gas and electricity. So the next implementation was at Q Solution, which is a specialist company providing managed services to UK government, and most recently at the National Archives. The National Archives, we are the archivist, official archivist and publisher for the UK government, and hold records such as the Doomsday Book, Magna Carta, but also many digital records, some of which are open to the public and some of which are actually highly confidential. So there's some of the implementations which I've been involved with over the last few years. All of them have been multi-cloud. So now I'm going to just draw from those different implementations and experiences some mistakes. So the first mistake that is commonly made, I would say, is using the native cloud security tooling. So this screenshot's actually from a Medium article by Ashish Chowdhury, and this is of Security Hub in AWS. And so you might think, well, actually this doesn't look too bad. We've got maybe 3 criticals, but this is just from a sort of test account, a single test account. In my experience, it's very easy with Security Hub to end up with, I remember, I have opened up Security Hub and seen literally thousands of critical vulnerabilities. And when you get thousands of vulnerabilities, you simply don't know where to start, and people just start ignoring them. So that's definitely an issue. another sort of issue with the native cloud security tooling. So this isn't just Security Hub, it's um, similarly Microsoft Defender for Cloud, which used to be Azure Security Center. You tend to get either a organization view of the whole org, or you get a view of just one AWS account or one Azure subscription. However, what's actually very useful from a business point of view is to get a view of maybe one department or one team that might look after, maybe 10 GCP projects, and you want a view for that whole area. And the last time I looked, none of them had that functionality. Might have changed, but the last time I looked, it didn't. So that's some of the issues. Another issue is, of course, that they tend to be single cloud. Some of them now are supporting multiple clouds. So, for instance, Microsoft Defender for Cloud does. But even if they do, then you'd expect, that they're going to sort of provide the best coverage of their own cloud. So I should just say, by the way, that since this screenshot's been taken, AWS has made significant improvements to Security Hub, and what you're seeing now is what's referred to as Security Hub CSPM, which is the sort of more legacy version, and they are making strides to improve this. So it may well be worth having another look, particularly if you're just in AWS. But nevertheless, in my experience so far, this has been a bit of a mistake to try and use them. They're also often, in some cases, not that easy to implement. For example, with Security Hub, you need config set up in all the accounts in all the regions, which can be a bit problematic. So it's certainly not necessarily straightforward and can actually be quite expensive. These aren't necessarily free, these native tools. So yeah, so that's one area that, in my personal experience, I've regarded as a bit of a mistake, really. The second sort of mistake, as it were, was sort of choosing what I would call a traditional cloud security posture management, or CSPM system, which really just looks at configuration against a set of rules. And this is a screenshot from one of the ones which I've worked with, and when you start getting 4,000 findings that are severe, you know, where do you start? Again, if you're getting this many findings, then people just ignore it and say, "Oh, forget it." This is ridiculous. So there are a couple of the what I would regard as mistakes. Let's move on to the successes. So the first sort of success, I guess, really is those systems which provide context. So this example is from Wiz. They're not the only cloud security platform provider to do this. Palo Alto, for example, does something similar with Prisma, and a lot of the others are sort of moving in this direction as well. But anyway, regardless of the the vendor, the concept is that so what Wiz does, for example, is they connect into all the clouds, which is great. They map all the resources, and then they plot all the resources on a graph database, looking for and make connections between the different resources. So in that way, they can build up a map of the different resources, and then they can make an assessment. So in this example, we have a vulnerability. Which might be, for example, a critical vulnerability. It's on a dependency within a Lambda function. And that Lambda function is exposed via an API gateway to the public internet. And that Lambda function also has a IAM role, and that IAM role has access to a database, and within that database, there's personal information. So because all of those things come together, this would be regarded as a critical issue in Wiz. Whereas if there was the same vulnerability and it was maybe on a server that was in a sandbox environment, it wasn't connected to the internet, it didn't have a role with access to personal data, then it would be classed as a medium issue. So in that way, there's the potential using this approach to actually prioritize those issues that really matter to the organization and should really be prioritized in order to reduce the business, overall risk to the business and the data, of that organization. So it's a very powerful approach. So that's, I would say, is the first sort of area of success, is implementing a system that uses this sort of approach. The second approach is democratisation. So this is a term I've also heard from Wiz. I don't know if they were the first to come up with it, but democratisation of security. So by that, what we mean is, we're taking a step back. In 10 years ago, the typical way that security was set up is that there'd be a central security team. That central security team would receive, all of the reports and vulnerabilities and issues, and then they would triage them, and then they would then chase the different departments or teams to actually fix those issues. And I've seen that in action at some organizations. And while that might have worked 10 years ago, well, I'm not even sure it worked then, but anyway, it might have worked 10 years ago when there were fewer vulnerabilities and less, not so much in the cloud, but it certainly doesn't work now. There's not enough skilled resource for the central team to do this. They'd be completely overwhelmed. It would be, very demotivating sort of job. So increasingly, what organizations are looking to do is to actually get the different engineering and developer teams to take ownership of the security of the applications and systems that they are responsible for. And to do that, it's necessary to provide the information using the tools that they use on a day-to-day basis and in a way that they can understand and be properly prioritized. So, for example, if it's a developer team, then, or an engineering team using infrastructure as code, then pull request integration is great. IDE plugins to Visual Studio Code or IntelliJ, for example, because then when the developer or engineer is coding, immediately there comes up an alert while they're typing, or just after they've typed it. It comes up with an alert to say, well, actually, that's an insecure way of configuring this infrastructure as code or writing this function. So it's very easy to change at that point and very low cost. If it misses the IDE or they don't have the plugin installed, then hopefully the pull request integration will capture that particular issue. And again, much easier to fix at this point than it is once it's deployed to production. So that's one area, providing the findings in the tools which people use every day. Similarly for notifications. If the developer teams use Slack, they need to get the alerts in Slack. Sending alerts in email is no good if they don't read their emails or only read them every few days. And also, for this to be successful, there needs to be a clear explanation of the issue so that the developer can really, clearly understand why it's important, and also have some suggestions for remediation. So, okay, but at the end of the day, we all want to see improvements. And this is from one of the organizations that I worked with, where the number of critical issues, and this is Wiz, this one, went down significantly, from when the system was installed to, and in 6 months we got the critical issues down to 0. Now, of course, they then might have arisen again, as new vulnerabilities come out, but that was a really good achievement. And that was completely down to, the combination of context and really democratization. So getting each team to feel a sense of ownership of their issues. The other, so moving on from some of the successes to some of the learnings, one of the first things, so when considering the use of a cloud security platform, inevitably there will be a proof of concept or proof of value sort of phase. Now, And that's completely understandable because these systems are expensive and the organization needs to be convinced that it's worth the money. So I'm going to be a little controversial here and say that I would personally recommend that, rather than do a sort of battle of, testing three or four, integrating them all and seeing which is the best, consider just doing one with a single vendor and choose the vendor carefully, obviously. You can choose the vendor on the basis of, Gartner or, chats, conversations with other organizations or looking at what your peers are doing and have found successful, demos and so on. But just doing the proof of concept with one vendor makes the most effective use of your security engineering scarce resource and means that you can make that a lot more in depth and really get a good feeling for what it will be like, if you then proceed to actually purchase it. So that would then, what I'd suggest is then negotiate a longer duration than normal, integrate all the clouds, have a very broad involvement during that proof of concept phase, including those individuals who actually make the budget decision. Second area of learning is automation. So there's a great benefit in implementing infrastructure as code and policy as code for the configuration of the cloud security platform itself. That makes it very predictable, scalable, and also, in the case of the policy particularly, provides a complete record of why different policies were created and the reasons for any exceptions. And you can also then identify which individuals in the organization or which teams the different exceptions in a policy might relate to. Another area of learning is use single sign-on. This is for authentication to the platform itself, to log on to the proof of platform itself, and to do this from as early a stage as possible. So for the ones which I've been involved with, we put that in right at the beginning of the proof of concept, and that helps with the broad involvement of getting more engineers and developers and senior managers to use the system. And whether that's with Entra ID or Okta or Google Workspace, that's very beneficial. Another sort of area of learning is the use of executive dashboards. And having different dashboards for developers, managers, and the security team. So the developers, and this may be, they may be custom dashboards, or this may be part of the functionality of the security platform that you purchase. This particular screenshot is from Aikido, who do a nice comparison report between teams. So yeah, so the developers just all they want to do is see their own issues. Or in fact, the developers probably just want to work with pull requests and IDE, but the team leads of the developer teams would want to see just mainly their own team. Then the managers might want to see several different teams, and then also for the more senior managers and the exec board, they'll want to see a sort of overall picture. And also, how that divides up between different departments. And that's not so much to put different departments in competition with each other, but it's really just to, more than anything, to sort of identify where, where somebody might need help or some additional resource. So that can be very valuable, having simple, easy to understand dashboards, for the and metrics that can get reported up, and that also helps. To prioritize security compared with feature requests for the product, from the leaders of the sprints. So yeah, so dashboards are great, and for security, of course, that they'll tend to want an overall view, but with the ability to drill down to look at more detail in different areas. So dashboards are really significant and helpful. And then really, I mean, this sort of harks back to the requirements, but it is, the more that you can integrate to the platform, the more value you'll get out of it. So yeah, if you can, not only setting up all the clouds, but setting up the different integrations to, for cloud events, vulnerabilities, container runtime, and so on. So that's very helpful as well. So I'm going to sort of wrap up now with a few takeaways. So do's and don'ts. So firstly, do make sure that you choose a context-aware vendor using the sort of approach which I've described. I would recommend considering at least a single vendor, more in-depth proof of concept. Yeah, use infrastructure as code and single sign-on, if possible, right from the beginning of the proof of concept. Integrate all the clouds as soon as possible. Ensure democratization, partly by choice of the right sort of product, but also by structuring the way that you've configured the platform to divide things up into different teams, and maybe doing some training, providing a bit of training, to the different teams. And then either build or use the built-in executive dashboards for reporting to senior management, which can help greatly as well. A couple of don'ts, which is just my personal opinions. I wouldn't choose a CSP built-in service. I mean, particularly if you're using more than one cloud. But even just if you're using one cloud, I probably might not. And don't use this sort of older legacy, CSPM just by itself. So with that, I'm going to just sort of wrap up. Well, say thank you, and feel free to get in touch. For those of you who are on the Cloud Security Forum Slack channel, that's a particularly easy way, straightforward way to get in touch with me. Quite a lot of people in SANS are members of that and can point you in the right direction. Equally, you can get in touch on LinkedIn, and feel free to get in touch and chat about any of the issues that you've heard here today. Thank you.